it is clear that there are systems that are easier to solve than others. For example, if I have to solve this system and this system, I prefer to solve this system. And the reason is that from the last equation, I can solve for x2. I can say x2 equal to 3/2. And then I can replace this information on the equation above, and then I get 2x1 plus 4 times 3/2 equal to 7. That means that 2x1 is 7 minus, here we have minus 6, and that means that x1 is 1/2. That means that one solution for this system is the point 1/2 and 3/2. Let me remind you that if you have an equation like this, 2x1 plus 2x2 equals 7, then this can be viewed as a system with one equation and two variables. One way to solve this system is to say that x1 is equal to, let's say 2x1 is 7 minus 2x2, and when I divide by 2, I get x1 is 7/2 minus x2. Then I can write the solution like this. x1, which is the first entry, is 7/2 minus x2, and the second entry is just x2, to indicate that x2 is free to be anything that you want. If you want to write this as a set, the solution set, then this would be the collection of points of this form, such that x2 is any, let's say, real number. We can pick particular solutions. For example, if we take x2, if we make x2 equal 0, then we can check that 7/2 and 0 is one of the infinitely many solutions. Or if we pick x2 equal 1, then we have 7/2 minus 2/2 is 5/2, 1. And then, like that, we can pick as many solutions as we want because we have infinitely many. But the point is that this is a system and it's not difficult to solve. Let me keep going with systems that are easy to solve. Somehow we're going to call those good systems. Let's say something like 3x1 plus 2x2 minus x3 equal 4, and x2 minus 3x3 equal, let's say, 4 again. Then in this case we can solve for the last equation, something similar to what we did here. We solve for the last equation, and then we can replace the information on the top. Let's see here how this goes. We can solve for this variable here, and I can say x2 is 4 plus 3x3, and then I can replace this information in the other equation, and I get 3x1 plus 2 times x2, but x2 I'm going to replace it with 4 plus 3x3 minus x3 equal 4, and then I'm going to solve for x1. Let's see, what do I get? I get 3s1 plus 8 plus 6x3 minus x3 equal 4. That means that 3x1 is equal to, let's simplify first, plus 8 plus 5x3 equal 4. And that means that 3x1 is equal to 4 minus 8 minus 5x3. And that means that x1 is negative 4 divided by 3 minus 5/3 of x3. Then, in this case, the solution set is going to be given by, we say like x1, x2, and x3. But we notice that x1 is negative 4/3 minus 5/3 of x3. x2 is 4 plus 3x3, and x3 is just any number. That means that if we want to write the solution set in a set form, then we have that this can be written as negative 4/3 minus 5/3 x3, 4 plus 3x3, and then x3, such that x3 is a number. I'm going to write a number instead of a real number because sometimes we're going to be considering complex numbers. Then let's see what these systems have in common. We notice that for these two systems, if we label the variables like x1, x2, x3, and we make sure that each equation is ordered like the first term that shows up is x1, the second one is x2, they are ordered in an increasing way, right? Every equation is ordered in an increasing way. Then we notice that the first variable that shows up in the last equation has an index that is bigger than the first variable that shows in the equation above. Then this classifies to be a good system. We will notice that when we have that property, we can do the same technique, which is called back substitution. Let me write it down. Back substitution. Let's see some other examples of what I'm referring to be a good system. A system like this, 2x1 minus 3x2 plus 4x3 minus 7x4 equal negative 2, 3x3 plus 2x4 equal 1, and 3x4 equal 7. Then in this case, the variables are x1, x2, x3, x4, and we can see that the last equation, the first variable that shows up is x4. In the previous equation, the first variable that shows up is one variable with an index that is smaller than x4, and in the equation above, the first variable that shows up is a variable with index smaller than x3. These variables, the first variable that shows up, somehow are going to play an important role, and the other variables also are going to play an important role. Essentially, when we do back substitution, we solve for these variables that first show up, and those that, the other variables, which in this case is x2, they are going to play a role of a parameter. Let me just do this system using back substitution. We have that x4 is 7/3, right? From here we get that 3x3 plus 2 times 7/3 equal 1. That means that 3x3 is equal to 1 minus 14/3, which is negative 11/3. And that means that x3 is negative 11 over 9. As you see, I'm solving for those variables that first shows up. And then from here we get that 2x1 minus 3x2 plus 4 times x3, but x3 is negative 11 over 9, minus 7 times x4, but x4 is 7 over 3. And then we have that this is equal to negative 2. That means that 2x2, we want to solve for x1, 2x1 is equal to 3x2 plus 44 over 9 minus 49 over 3 minus 2. Sorry, here is a plus. And this is equal to 3x2 minus 173 over 9. And that means that x1 is 3/2 of x2 minus 173 over 18. That means that the solution set for this equation would be like x1 is 3/2 of x2 minus 173 over 18. X2, what is x2? X2 is the one that didn't get the chance to be a first variable in one of the equations, and then that's going to be used as a parameter. x2 is equal to x2, x3 is minus 11 over 9, and x4 is 7/3. Then the solution set would be like x1, x2, x3, and x4, such that x2 is a number. And this is the solution set. Then let me try to explain this in general. What is a good system? And that means a system in which we can do this back substitution and get a good answer. Let me erase this. Please do this homework. Let me continue explaining how to check if a system is a good system. One of the conditions is that if we have in this system one equation that looks like this, 0x1 plus 0xn equals 0, that means the equation 0 equals 0. Or if we have several of these equations, they must be at the end of the list of equations. Let's do an example. If we have like 3x1 plus 2x2 plus 3x3 minus x4 equals 0, 0x1 plus 0x2 plus 0x3 plus 0x4 equals 0, 2x1 plus 2x2 minus x3 plus 7x4 equals 10, and 0x1 plus 0x2 plus 0x3 plus 0x4 equal 0. Then in this case we notice that we have equations of this type. We have 1 and 2, and they are not at the end. This one is at the end, but this one is not at the end. Therefore, this does not classify as a good system. We will have to change the order of these two equations so that the equations of this type, they must be at the end. The other condition is that if we have an equation of this type, like let's say equal to some b, that means 0 equal b, with b different from 0. If we have an equation like this, let's say the same system but here a 3, then an equation of this type must be above any equation of this type, if any. Then if there is any equations of this type, this one must be right above those equations. And if there are any equation of the form equals 0 like this must be at the end, and only one of those is possible. Let's see. in this case, if we have something like this does not classify to be a good system because, again, we will have to change the order of these two so that an equation of this type is above an equation of this type. Let's see another example. 2x1 plus 2x2 equal 4 and 0x1 plus 0x2 equals 7. This is an example of a good system. The reason is that in this case, we don't have equations of the form 0 equals 0, and then an equation of this type must be at the end of the equation. Then we have that, and this is just the case in which this type of equations like 0 equal b or 0 equal 0 shows up. But in general, if those equations don't show up, then what we are going to do is we're going to make sure to organize every equation in such a way that the variable shows up in increasing order, like x1 and x2, and then they keep increasing, something like 2x1 plus x3 minus x5 equal 2, 3x2 plus 4x3 minus plus x5 equal 2, and x1 plus 3x2 minus x3 plus x4 minus x5 equals 7. Then we have to check that in each equation, the order in which the variable shows up, they are in increasing order, like x1, then x1 is smaller than 3, is smaller than 5, 2 is smaller than 3, is smaller than 5, 1 is smaller than 2, smaller than 3, smaller than 4, and smaller than 5. They must be show up in increasing order. And when you have that, then in order to classify to be a good system, we need to check that the first variable that shows up in the last equation, this first variable that shows up in the last equation must have an index x1. It must have an index bigger than the first variable that shows up in the equation above. Then in this case, for this reason, this system is not a good system. It's not a good system because here the first variable that shows up is x1, but the first variable that shows up in the equation above it has an index that is bigger than x1. Then for that reason, this is not a good system. Let me change the system. If I make it like this is not a good system either, because here the first variable that shows up in the last equation, it doesn't have an index that is bigger than the first variable that shows up in the equation above it. Right? And actually the condition is satisfied here. Right? The first variable that shows up here, it has an index that is bigger than the first variable that shows up in the equation above it. But this must be true for every equation. Then in this case, this is not a good system. And let me write this, not a good system. And now if I change the system to be like this, let me say 3x2, then this is an example of a good system. The reason is that the first variable that shows up in the last equation, it has an index x4, and the index is bigger than the first variable that shows up in the equation above it. This one has index x2, and this one has index bigger than the first variable that shows up in the equation above it. Then we have a good system when the first variable that shows up in an equation, it has an index bigger than the index of the first variable that shows up in the equation above it. Let me write this down. It means that the index of the first variable that shows up in an equation is bigger than the index of the first variable that shows up in any equation above it. For example, here the first variable that shows up here is x4. This index 4 is bigger than the index of the first variable that shows up here and the index that shows up in this equation too, right? Then this is the condition to have a good system. Then let me refer to some notation. This first, when we have a good system, these first variables are going to be called basic variables. Then collection of first variables, collection of first variables, yeah, let's say it like that, are going to be called basic variables. And the other variables are going to be called free variables. Then this is the notion of basic variable and free variable. Then for this system, we agree this is a good system. Then the basic variables are going to be x1, x2, and x4, and the free variables are going to be x3 and x5. Let's do more examples of these basic variables and free variables. Do this example. If we have a system like 3x1 minus 17x2 equal 14, then this is a good system. There is only one equation, nothing to check, and in this case x1 is basic, and because this is a first variable that shows up in an equation, and x2 is a free variable. And this is a basic variable and this is a free variable. Let's do another example. If we have 3x1 plus 2x2 minus 7x3 equal 4 and 3x3 equal negative 5, then this is a good system, because the first variable that shows up in this equation, it has an index that is larger than the first variable that shows up in any equation above it. In this case, x3, the index 3 is bigger than the index 1. Then the first variable that shows up when we have a good system, this definition of basic variable and free variable only work when we have a good system. Then these first variables, which are x1 and x3, are called basic variables. And those variables that are not basic are called free variables. x2 is a free variable. And the idea is that when we find the solution of a system, we will write the basic variables in terms of the free variables. Let me do this with this example. In this case, x3, for this system, we solve for the basic variables and we can use the numbers or free variables. Then x3 is negative 5/3. In this case, we only use a number. But then we solve for x1 from here. We get 3x1 plus 2x2 minus 7 times x3. That means minus 7 times negative 5/3 equal to 4. And that means that 3x1 equal to negative 2x2. This is a positive. Then it will be minus 35/3 plus 4. And this is equal to negative 2x2 minus 35/3 plus 12/3, which is negative 2x2. 32, we have 18 minus 23/3. And that means that x1 is negative 2/3 x2 minus 23/9 minus 23/9. Right? This is x1, this is x3, and x2 is a free variable. Then in this case, the solution set is going to look like, let me write solution set. It's going to look like, what is x1? x1 is negative 2/3 x2 minus 23/9. x2 is free. That means that x2 can be any number. That's allowed to be part of the answer. And x3 is going to be negative 5/3. And then we say the points like this such that x2 is a number. This is the solution set. Then in general, we're going to use the free variables as parameters, and we're going to solve for the basic, and then we're going to organize the solution like this. Please do this homework.